All right, so we're going to graph these. Graphing these, the first thing we want to think about is what the graph should look like. Okay, so that's what we talked about in the very first section. So we're going to have to kind of remember what end behavior does. So we want to get an idea of what the graph should look like first, based off the leading coefficient and the highest exponent. Okay. Once when we've done that, we're just going to make an XY chart to plot some points, and then plot those points on there and make sure our graph looks like what we thought the sketch was. Once when we have the graph made, we're going to identify where zeros occur. So that's going to be where you cross the x-axis. And then state any maximum or minimum values. So you're going to state the point if you have a high point, or if you have a low point, you're going to state where those happen as well. Okay, so those we have to actually look at the graph to be able to find. So for starters, this is a highest exponent of 4. Okay, so is this an odd function or an even function? It's even, which means which way do the ends of the graph go? Yeah, they're both going to go up. So we know because that this is to the 4th power here, both ends of the graph end up going up. Okay? We know that from the first value because it's the 4th and it's a positive number out in front, so we're going to end up. Now, we can actually know kind of what the middle looks like. For every exponent you have, the graph kind of does a turn. So you just count. So this is 1st power, 2nd power, 3rd power, 4th power. So the graph should look something like that. Okay, so I'll show that again. So this is 1st power, 2nd power, 3rd power, 4th power. Now, the dips or the valleys or the peaks might be completely different sizes. They might be very little ones. They might be very large ones. That's what we need to find out by plugging points in. Okay, so when we get done with this graph, it should look something along these lines. The leading coefficient determines the right-hand side if it's going up or down. So since it's a positive, we are up on the right-hand side. Yep, and the highest exponent is what we're looking at. Okay, so we know kind of what the graph should look like. So now let's start plugging some points in here. So you can do this a few different ways. You can do it by actually taking the points and plugging it into each x value. Or you can do synthetic division and just look at the remainders. I like synthetic division a little bit better, just because then you won't make errors with negative signs. But you can do it whichever way. And here there is no plain number, so you do need to make sure you add a 0 at the very end. So then if you set it up like this, your x values are way over to the left, and your y values is your remainder column. Okay. And then you just want to try some points here. And you want to try enough points so that you get this general shape. Once you have this general shape, you're done. Okay, if you don't have that general shape, then you'll have to try a few others on either before or after. So I don't know, let's start with, let's go -2 to +2 and see what happens. And then we can either add on to those values or take away from those values from there. So we'll start with -2. And we need to figure out what the remainder should be. So we can do synthetic. So we drop down the 1. We multiply to get -2. Add to 1 and get what? -1. Multiply, +2. Add to -4. -2. Multiply to get 4. Add to -4. 0. Multiply. 0. Add to 0 and get 0. So one of our points on our graph is going to be at -2, 0.
So it has to, like, the remainder is less than 0?
No, the remainder can be any number. That'll just tell us where on the graph to go. So this is negative 2, 0, so that tells us that we have this point right here at negative 2, 0. Yep, or by looking at the graph, and we'll do an example where we don't have the exact zeros as well. So let's try negative 1 now and do the same thing. Figure out where this goes. 1 times negative 1. Negative 1 added on to 1. 0. 0 times negative 1. 0 added to negative 4. Negative 4 times negative 1. Positive 4 added to negative 4. 0, 0 times negative 1. Add it to 0 and get, oh, what does that tell you? Negative 1, 0 is also a point. Okay, what will we get when we plug 0 in? 0. So 0, 0 is also a point. Oh, there's a reason why we're doing this one. Number 1, so we drop the 1 down, we multiply. 1 times 1 is 1. Added on to 1, we get 2. 2 times 1, 2. Added on to negative 4, negative 2. Negative 2 times 1, negative 2. Added on to negative 4. Negative 6 times 1, added to 0. Negative 6. So finally we have another point, 1, negative 6.
We have to go further over the
Yeah, we're going to have to keep going in some different directions here. So let's go with 2 as well. So we drop down the 1. 1 times 2. 2. Add it to 1. 3. 2 times 3. 6, add it to negative 4, 2. 2 times 2, 4, add it to negative 4, 0, and then this one will also be 0, 2, 0. Okay, what's this graph supposed to look like? It's supposed to look like that. Okay, so right now, what do we have? We definitely have it going down, and we have it going back up to here, right? So we need to figure out, we need a point that goes back up. Okay, so we need to figure out what's happening in between these two, because right now it's just a straight line between these two. So what would be a point in between 0 and 1 that we could do? Negative a half. And then what would be a point in between negative 2 and negative 1 we could do? Yeah, negative 1.5. So we could try those two and see what we get, and hopefully that'll finish off our graph for us. And we'll see that it's going back up. So if we fill in negative 1/2. So 1 times negative a half plus 1, a half. Right? Okay, a half times negative a half is negative 1/4 plus negative 4. Yep, negative 4 to 4th. If you want to use decimals, you can use decimals. That's fine. Negative 4 1/4 times negative a half. Yep, negative 2 or positive 2 1/8, because they're both negatives. So 2 1/8 plus negative 4. A positive 2 1/8 plus a negative 4.
Negative 1 7/8.
Yep, negative 1 7/8. And then negative 1 7/8 times negative a half. 15/16. Okay, so at negative a half, we are at 15/16, which is kind of close to what number? 1. So it's right up here. Okay, so now we see we're definitely going back up and coming back down. Okay, so we still need to make sure we go down, and then hopefully we go down here so we can just shoot back up. So that would be the point negative 1 1/2 we have to do. This is where using your calculator will probably be helpful for you here, because I know a lot of you are not super quick with fractions. So 1 times negative 1 and a half, negative 1 and a half plus 1, just negative half. Negative a half times negative 1 and a half. What? 3/4. 3/4 plus negative 4. Yep, negative 3 1/4. Negative 3 1/4 times negative 1 and a half. 4 7/8. 4 7/8 plus negative 4. 7/8. And then 7/8 times negative 1 and a half. Yep, negative 1 and 5/16 plus 0, so negative 1 and 5/16. So that does go down. Goes down to negative 1 and, I don't know, right about there. We're just guessing. And then is it going to go back up to that point? Do we need to find another point over here, or do we already have the shape? We already have the shape. No point to do negative 3, so we'll just shoot it right back up. This is the type of difficulty that they all are about this. Some of them are a little bit simpler than this because you don't have to try in between points. Is everyone okay with how we got this graph? Okay. So, you can plug x, y. You can just plug your points in for your x as well. I just find synthetic division a little bit easier because you don't have to worry about exponents. Yeah, because you don't have to worry about exponents, and so you won't make negative signs, errors. So there's our graph. So we want to state where the zeros occur. Well, for this one, the zeros occurred at exact points, right? So where are those 4 points at? Because those 4 points right there are our zeros. So the zeros are at x equals negative 2, negative 1. That was a bad place for me to write it. We'll go up here. Zeros are at negative 2, negative 1, 0, and positive 2. Okay, so we have 4 zeros. There's the 4 places where across the x-axis. Okay?
Do you know that?
Yeah, we also would know that from right here because of these 4 zeros. So we could know that either from our chart or from looking at our graph. And then the other part that we have to do here is we have to say where the maximum and the minimum happens. Now, we don't include these arrows as being a maximum because that's going to keep going up and up forever. So there will be no true maximum of this graph. Okay? But there's a relative maximum, so meaning that there's a little hump in this graph where it does hit a high point, and it would happen right here, right in this area. Okay, so you see our graph goes up and back down. So this point right here would be our max point. And we're just going to say what x value we were at for this point. So what was our x value here? Yeah, our x value was negative a half. So our max here is at about x equals negative 1/2. And when it comes to fractions or in between points like this, the max might actually be at negative 1/4 here, but we're not going to try every single point. We're just going to use the point we used. And then the minimum, so look, so now where on this graph are we at the lowest? Yeah, right here. Right here is where we're at the lowest, so that would be our minimum. So we'd say the minimum is at x equals, what was our x value for that? 1. So we have our maximum, we have our minimum, we have our zeros, and we have our graph. Is that okay? Yes? Okay, we'll do another one together. Yeah, we'll do this one. Number 2, f of x is equal to x cubed minus 5x squared plus 3x plus 2. If you have a tie for a max or a min, list them both. So if they both are at the same max height, just list both x values that it was at. Okay, so x to the third minus 5x squared plus 3x plus 2. So what's our leading coefficient? Is it positive or negative? Positive. So that means on the right-hand side of this graph, are we starting up or are we starting down? Up. Okay, so my little sketch here is I start up on the right-hand side, and I'm to the third power. So we would have first power, second power, third power. So my graph should look something like this at the end. Okay, and that step is really important that we know what the graph looks like. Otherwise, when we're plotting the points, we don't know when to stop. Okay? Otherwise, we're not sure if we actually have the graph or not. So it's important that you have an idea of what the graph should look like. Okay, what should we do next so that we could start getting some points on here? Okay, so let's set up synthetic. So we've got 1, -5, 3, and 2. This would be our x, and our remainder would be our y. Okay, and generally speaking, we always just start right around -2 to 2. Yep, let's say at -2 you get a number that's like 100 though. Then probably try 0 and see if you're any closer to on the graph. So use your judgment. If you get really, really high remainders here, it's, then you want to move one way or the other. But generally speaking, that's a good area to start with. So if we try -2 here, 1 times -2 is -2, add it to -5, -7. -7 times -2, 14, add it to 3, 17. 17 times -2, -34, add it to 2, -32. That's pretty low, right? What would we be at 0 here? See, we're really far off the graph, so let's skip -1 for a minute. Let's think about what we would have for 0. Yeah, 0 would just give us 2, because all of those values would be 0. So that's a pretty big difference between these two, so we also should do -1 to see what's going on, because it might dip. Okay, so plug in -1, so drop the 1. -1 times 1. -1, add it to -5. -6, -6 times -1. 6, add it to 3. 9. 9 times -1. -9, and add it to 2. All right, -7. So let's plot some of these points on here so we see what's happening. So at -1, we are at 1, 2, 3, 4, 5, 6, 7. We're at -7. At 0, we are at 2. At -2, we are way off the graph. So does this look like it's this left-hand side of this graph right now? Looks like it's starting to come up. So we need to make sure that this graph goes back down and comes back up. So that's what we need to find. So let's go for 1. Hopefully 1 will show that we're going back down. So drop down your 1, and then 1 times 1. 1 plus -5. -4. -4 times 1. -4, add your 3. -1. -1 times 1. -1, add it to 2. 1. So we have the point 1, 1. Well, good. So that shows that we're dropping back down. So we could start drawing this in, and we see that we are definitely dropping back down. Hopefully at 2, we go back up. If we go back up, then we have the general shape of our graph. We'll see. So 2, so we drop the 1 down. 1 times 2. 2, add it to -5. -3. -3 times 2. -6, add it to 3. -6 plus 3? I just didn't hear you. -3. -3 times 2. -6, add it to 2. -4. All right, so at 2, we are at 1, 2, 3, 4, negative 4. Oh, so we continue to go down. Okay, so what does this tell us? Do we have that shape yet? No. So then what number should we try to?
3.
Yep, try 3. Now hopefully at 3 it'll show that we're going back up. So drop your 1. 3 times 1. 3, add it to negative 5. Negative 2. Negative 2 times 3. Negative 6, add it to 3. Negative 3. Negative 3 times 3. Negative 9, add it to 7. Man, we just keep going back down. Okay, so we go down even further. So we're still not at that shape yet. So then what do we have to do?
Just skip ahead 5.
Just, well, we'd probably go to 4, right? Okay, so now we'll plug 4 in. So 4 times 1. 4, add it to negative 5. Negative 1 times 4. Negative 4, add it to 3. Negative 1 times 4. Negative 4, add it to 2. Ooh, there we go. 1, 2, 3, 4 at negative 2. So now we see it turns back up. Since it turns back up, we can just keep drawing it up, and now we have the general shape. Okay, I find it best to graph it as you do the points how we were going. Because sometimes otherwise when you just plot all the points after, you might have a difficult time trying to figure out which point actually goes to which point. Okay, so I would definitely, like how we were doing in this example, graph it kind of as you're going. These don't have to be perfect, they just have to be, you know, what the graph generally looks like. So on here, do we have any exact values for zeros? Did we get any zeros over there? No. Okay, so there are 2 ways that we can identify our zeros. Option number 1 is to actually just look at your graph. And if you did a good enough job of drawing your graph, you should be able to see in between which 2 numbers they happen. So for zeros here, I'm going to say in between because they don't happen at exact numbers. Here's where I crossed the x-axis the first time. What 2 x values is this in between? 0 and negative 1. So in between 0 and negative 1. Okay, here's where I cross the x-axis the next time. What 2 values would that be in between? So in between 0 and negative 1, 1 and 2. And then over here, it looks like there, but it's really crossing over a little bit over further if I had graphed that a little bit better. So there we go. So over here, we're in between 1, 2, 3, 4, and 5. So in between 4 and 5. Yep. Those are just and symbols. So in between 0 and 1 and negative 1, 1 and 2, 4 and 5.
So for your maximum, would that be just that little number?
Yep, we'll get to the max in just a second. The other way that you can tell this is by looking at your chart over here. Notice every time you switch signs. So here we went from a negative number to a positive number. That tells us that we have a 0. So that means one of our zeros would be in between negative 1 and 0. Here we switched from a 1 to a negative 4. So that tells us that one of our zeros should be in between 1 and 2. And remember when you did this, when you were solving these values, and if you saw a jump like this, that was an indication to try the fractions in between negative 1 and 0 to try to get the actual value. So that was one of your clues when you were solving these. So that's a clue as to where the zeros lie between. And then for this last one, you could take the liberty to assume that this would be some positive number here at 5 because we know it's treading up. So those would be your 3 zeros in between those values. So either way, however you want to tell, it works. So now we have to state what the max and the mins are. So the maximum value here, so here we go up and we have this hump right here, this peak. So that would be our maximum value, and what's our x value for this? 0. So our max is at x equals 0. Okay. The minimum, so down here we got this valley. So what's that x value? 1, 2, 3. So the minimum is at x equals 3. You can tell those as well by looking over at your synthetic division, by looking at the trends. So here, you see you go from -7 to +2 to 1. So you see you go down, up, and down. So that would tell us we have a maximum at 0. And then right here, you go -4, -7, -2. So we go down and back up. So that would tell us we would have a minimum at 3. So you can also tell those from your charts. It doesn't matter which way you do it. Does this sort of make some sense? Yes?